Engineering lectures are going on, and it has generated a lot of interest amongst the students. They are also trying prompt engineering for their own research. So thanks to Rudra and Amar for discussing this topic with us, a very relevant topic. So let's go ahead. Prompt over to you. Amar, over to you.
Sure, sure. Thanks a lot, sir. Yeah, I mean that was definitely one of the important motivation to basically excite people and I think it's because this area is catching up very fast, and I don't know how long this will stay as well. The
Yeah.
way things moves very fast in NLP nowadays, yeah. Yeah. So I think last couple of uh, s- talks we have covered quite a few things about what actually, I mean, how this prompt started. I mean, what are the fundamentals of this, and basically how this is posed in the NLP evolution here, and where we are. And we have gone into some more details about some of the methods, and especially last lecture we're more detailed about some of the important models, specifically in the discrete prompting. Uh, um, um, I mean approaches. Uh, so what I was thinking, actually, we should cover some of the other aspects of prompting, some of the other approaches of prompting, such as continuous prompting, and a little bit about multi-prompting, and maybe try to understand a bigger picture of that. I mean, these are something I wouldn't call it like a, I mean, it's like a best pictures, but some of this actually what are our views. I mean, we were thinking what me and Rudra as well, and in fact, this is a point maybe. Sir, you can also put your views there. That will be very helpful for all of us. Uh, anyone who has more understanding, and then I mean we can discuss on them. These are open things to talk about, and maybe some of the open research questions that actually arises because of this all understanding of prompting. Possibly some of them might be important, and possibly some might be very obvious. But let's see about those. So that's what I'm trying to. We will try to complete this in this talk, and maybe maybe let's see how it goes. So I think going forward from a discrete prompting methods, we have seen that we try to, I mean, the idea was there in by some of the work that figure out what are the possible words that you can put, whether it's a prefix or something before the content of the text, such that you can find, I mean, right, I mean, basically the model should be able to, I mean, respond with the right correct answers, whether it's in terms of sentiments or in terms of some other answers. Uh, the problem there was that because the words are very much in discrete space, that those might not be optimal. Many times those may not make sense if you try to make it more and more optimal. So that actually started triggered the idea that it looks like that better prompts are one which actually which are not very much making sense to us, but maybe making sense to the model, because putting those things in the language model, I mean, we are moving, or we are pushing the language model to go towards the right level answer space basically. So why don't look into the continuous space set and find the best possible prompt, and possibly that's the best way of optimizing, I mean, some function, and we do it very regularly in deep learning models, right? So that was the whole idea about that. Uh, and quite a few work actually have touched upon that. And I think the next question then will come, that is it the best possible prompt, and then best possible prompt in what sense? That also, I mean, basically some of the papers have tried to answer that, and in fact still many things are left open, that what do we mean by best possible prompt, in what sense, and all those things. So, so one of the work actually is pretty much important in this area, is prefix tuning and their, I mean, following literature. So I thought, let me just go a little bit in like touching a little bit in detail about prefix tuning. So in prefix tuning, basically they bring this point here. Uh, so in GPT-3 and all, which is called which is also called in some sense in context learning, has happened in GP3 in the sense that, I mean, uh, given the context, actually just gives you answers. So because of that, it's called that. Uh, but this kind of like learning cannot be exploited. I mean, so once the model is learned, we cannot use any large training sets into it. So that is one of the different demerit of that. But many times it may not be required as well. And what it allows you to give some manual written prompts. It may not allow you to give you some kind of embedding kind of some other sort of prompt without I mean besides manual. And I think the earlier discussions has clearly identified that manual prompts may not be optimal all the time. So the other paradigm of that, if you look, that is something where we do often, that we fine tune a model, and the fine tune, of course, we we push them, we give a large amount of data, and we come basically 100 all parameters are fine tuned. So this is slightly heavy, and it's something which you want to go away from that as well. That definitely most likely that is optimal in the sense of the task for which is fine tuned. Uh, but can we do something in between? And that is where a prefix tuning comes into picture. So the idea of prefix tuning is that can we do similar like fine tuning, but don't touch the parameters of transfer model. And when we say transfer model, because those are the ones which has large language models and they are trained on large data. So let's not touch about that, but then tune or fine tune some of the parameters that you can attach before the model in many manners you can do that, and let them let's try to optimize that in a continuous manner. So it's basically a very small amount of parameters to be optimized, and highly likely that you might be able to get possibly uh, best prompt in, of course, under the constraint that what is the size of your prefix and all those things. But I mean, if you consider that we have the ability to basically expand the size of prefix and all those things, possibly you will get the optimal prompting. So in some sense, some sense what you're saying that this is the best you can achieve uh, under assumptions. So and this is very lightweight as well. So this is a very key benefit of prefix tuning, that what people argue about. And if you want to compare that with the prefix with the fine tuning, so it's obvious what I was saying. In fine tuning, you basically to optimize for large number of parameters, and this is very lightweight. So 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 we are actually leveraging the transformers, learn transformer, which is done which is very compute intensive and might have taken a lot of time. Uh, On the other hand, actually, this prefix tuning may also allow you to basically figure out some kind of like prompts which are for different tasks individually, or maybe depending on your configuration of your modeling, you might get a single prompt for many tasks together as well. So this is something we can think about prefix tuning versus fine tuning. And if you think from the point of view of context tuning, in prefix tuning you can actually you're not limited uh, with the manual prompts, basically text prompts. So sorry, I think I forgot to tell one thing. So all the prefix tuning gets you optimal, but it's very difficult to interpret them, because that's basically trying to get you some sort of like embedding vector, which is very difficult to understand what it means to us. Uh, in context learning, you were able to understand because you were giving the manual prompt. So this is the pros and cons for prefix tuning. Uh, but on the other side, in prefix tuning, you would be able to exploit the training data if you have. I mean, in fact, you will, when you're optimizing that, you might be able to use some training data, and you may not need to use a lot of training data for certain tasks, because the parameters to be optimized is very small in numbers. So this is pros and cons with respect to the context learning here. And feel free to ask any questions if anybody has in between. So, so what is it? I mean, if you try to find what is intuition behind this prefix tuning. Um, so I mean, if you just go back a little bit and see this in discrete, when we're doing discrete instructions for or discrete optimizations, what we have seen in earlier, Rudra has to say something. Oh, can you go ahead, Rudra?
Yeah, sure, Amar. So the intuition behind prefix tuning is, uh, see, in the descript space, we attach some natural language prompts, right? And we found out that the natural language prompts are often suboptimal. And if we try to find those natural language prompts, say in an automated fashion, they're often uninterpretable. So basically, what prefix tuning says is, instead of trying to find these prompts in the discrete space, let's try to find the prompts in the continuous space. So when they say continuous space, we provide some representation to the transformer, and these representations steer the transformers in generating the right output. Say, for example, in this case, you have, so this is the example of question answering, right? Starbucks type coffee shop,
Uh,
Starbucks. Yeah,
yeah,
man.
go ahead, go ahead. Yeah, no, I think this is just summarized and put table to text, but it's okay.
Okay, okay.
It doesn't matter much.
Summarization.
Yeah, yeah. Mm.
Yeah. And now the goal is to learn these prefix representations. So that's what prefix tuning tries to do. And the claim is these representations might be uninterpretable. It might not make sense, but by optimizing a very small number of parameters, which is these prefix parameters, we are able to query the language model in getting the right result.
Yeah, that's very much correct. Okay, thanks, Rudra. Uh,
There is a question on the chat box.
yeah, I see that. Actually, unfortunately, I have to open it separately. Yeah, okay.
Oh, should I read it?
No, no, I can read, sir.
You
So
can
when
share
we
it.
say prompt, we refer to a template to augment the input, right? Do we? Girish, why don't you directly ask the question? What your question is?
Hello, Omar.
Yeah.
Uh, uh, I mean, in your screen, so I see that this text to text, that is a prompt, right? A prefix, uh,
Hmm.
which we use to augment the input. And then that augmented input will be fed to encoder or large language model.
Whatsoever. Yeah. Go ahead. Huh?
But is there any, so now, I mean, after this BERT and now T5 and BART and those models are kind of text to text based models. So output is also direct text. Is there any example where just like input augmentation, uh, which deals with augmenting output sequences as well? So just like
I mean, you mean to say reverse kind of situation where you can augment in the output and you get the right answer?
yes. So something
Yeah.
like if I'm training a model for English to multiple Indian language translation, then just before I start generating sequence on the target side, I say that Gujarati or Hindi with this type of prefix to say that okay, system need to generate text for that mention language.
Mm-hmm. Mm-hmm. So yeah, I mean, I think that is obviously that's something like a, I mean, the bigger umbrella of the prompting, right? That I think the prompt, I would say that prompting is inspired from those kind of things, that you just change the some token in the input, and actually that will make the your language model to be able to predict according to that, right? Just now what you mentioned, and this
Okay.
has been done a lot in translations, right? So you have a common translator and you just give a prefix to English or Gujarati or Hindi, it will give you translation in that language, right?
Yes, yes, sir. So if
That is
any
again input augmentation, right?
yes, yes. So yeah, so translate to German. If I'm writing in this way, then it's a kind of input. But instead of mentioning that German on the input side, if I mention it on output side, is there any example or do people have tried this kind of target
um
side?
I don't know about that, if there is some augmentation output side, and I think the reasoning behind that is that whole idea is that you want to solve a task, so you give an input to a language model and you get the output. So whatever you are asking what you want to ask the language model to do, and that you can augment only in the input side. So that is something. But on the I mean, if you I mean there are some situations where what exactly you want in the output that you may not get, and then you want to map that. For example, in sentiment analysis, if you have text to text, I think some of example in the first lecture I had given. Let me see if I have that. Yeah. So some it's called answer mapping. So for example, like if you look at that, you might actually give an input. I love this problem, and there's a template which gives you some answer, which gives you fantastic. But what your final outcome you desire is basically a sentiment labels, right? So you need to have an answer mapping there, which actually maps these uh, uh, label words into the kind of label, right? So those are actually part of things what are done actually basically to extend the output to the right I mean template you want to have. But the augmentation are generally done in the input side itself. And I
Okay.
think yeah. And I think so Rudra also said you something about this is one of the greatest movie in the film history. This example what he gives you, I mean some examples he's giving that. And I
So
think those
Amar,
all
this
are
was for Narji's question.
okay, sorry.
I'm not answering Girish's question.
Okay,
This
okay,
is for
okay, no
Narjis.
problems. Did it answer you, Girish?
Yes, I got clarity. Thanks so much.
Okay, great. Okay, so let's go ahead with that. So idea will what actually, if you see intuitively what actually it is. So in prefix tuning, what the idea is to optimize the instructions and how to do that. Basically, move from discrete to continuous space, and it's more or less like when you're talking about generative models, right? So it's like condition to what your context you have. And here in this particular case, what you're seeing that, I mean, from this will give you intuition that what are these two embeddings basically are that you give as a conditional input or condition as a context to the model, and it will actually accordingly generate the output. So basically, you're extending the context in some sense. That's what is intuition here. And so there is so and that's what actually I mean, I mean, here, I mean, in this, I mean, this here we are trying to expand that notion of that these prefixes need not to be only in the lower layer. You can actually, this was only in the first layer, and this can be actually extended to all the layers of transformers. Means basically all the L layers of the same, I mean, all the L layers, and whether you can have that uh, shared kind of prefixes or unshared kind of prefixes, but the idea is that basically can you optimize and find the best solution out of it. That's basically from the intuition point of view, you can think of that like context expansion, and that expansion happens actually in a expansion can happen at any whatever layer that depending on your design. I mean the way you are designing the prefixes. I mean, that's what you can, I mean, that's how you can actually get intuition of prefixes. And I think, I guess I had just touched upon this earlier also. So there are a couple of papers which are very, I would say, interesting papers in this area. And this is one is prefix tuning and another prompt tuning. And there's subtle difference in prefix and prompt tuning. And I think I was also just touched about that. So the basically prompt tuning is the one when we say prompt, basically that means something we are just appending in the text input, but prefixes need not to be appending only to the text input. It can be actually it's basically expansion of a transformer itself, but it is not the transformer part getting expanded. There is some additional layer which is more or less some MLP layers which you append or prepend before the transformers, and that can be according to design that can be put into whether multiple layers or all of that. So multiple layers or single layers, and of course shared or non-shared, and those are called prefixes, and other where you just append in the text is called prompt, and both can be tuned in a similar manner. So that they are two different papers and they talk about two different things, but they are very closely related to each other.
Amar, may I ask a question?
Yeah, please
Small.
go ahead.
So, in this prefix tuning, does the length of input increases the way it increases in prompt-based thing?
So they have done the study with like very I would say variable length of prefixes, and what they observe is that when you initially increase the length of prefixes, it actually helps to improve your performance of your task, but up to some extent. And again, that varies with respect to the task what you have at hand.
So, I'm a little
In fact,
confused
they have
actually.
done till 300 size of basically prefix embeddings.
So I'm a little confused actually. So let's say that sentiment example, right? So we put the movie was X, and then if it's awesome, then it's positive, probably positive. If it's something else, it's negative, right? So basically, we put three additional tokens, and which puts it into the discrete space. So are we trying to do like similarly here that we put three additional, not tokens, but three additional, let's say, embeddings, and those embeddings might not correspond to any token, but that's what you learn, which could be potentially a function of your input. Is this what we are doing here?
Yeah, very much true.
Okay. Okay.
And I think these are the questions which I want to open more in the which way, I mean, after this finishing of the content here.
I see. Okay.
And they're very interesting points actually. So what actually we are doing here? I mean, are we moving our optimization or basically learning part from one place to another? I mean, is it just a fancy way of learning something else than what we are usually used to learn in fine tuning or training, or something else we are doing? And that's the whole. I mean, the buzz going on. What actually is happening in this area?
Right. So actually, the way we do fine tuning, right? So there is something called adapter modules. So instead of doing fine
Right,
tuning,
right,
right? So
right.
this is different from that, right? In adapter modules, we don't increase the
Actually,
length of
it is
input.
inspired from that. It is
Acha, okay.
somewhere. Basically, adapter model has come some time earlier,
Yeah, yeah, right,
and I mean this has come some advancement over that adapter basically.
right. So
I
if I have
wouldn't
to,
call it like they're
yeah.
just very different than adapter. This is of course stage by stage, right? So it's
Right,
something in that
correct,
term.
correct. So I think to me it looks like in adapter sort of models, your input length, right? So let's say Starbucks type coffee shop, total length is
Right.
including it's 15. In those models, that length doesn't change. Here it is changing by some amount, and that depends on the model and learning and so on. That's the basic difference it looks like.
Uh, no, the prefix is not trying to change your input. It's basically trying. I mean, indirectly, it's changing the length of input, but
Right,
but in the embedding
correct,
space itself, that's the whole. I mean, idea is that
right.
take it to the sky limit.
Right,
Under the setting is very important because the sky limit may not be real sky limit.
right, right.
So
So
the setting is fixed, then to take
mhm.
it to sky limit.
Right. So to the end user, it will not show that my input length is increased, but internally it is increasing using say this prefix sort of
You're right.
thing.
The
And
transformer is seeing the input length has increased basically.
right.
Mm, So, Amar, I'd like to interrupt and say that it's not really increasing the input length.
Is it okay? Uh-huh.
No, Rudra, actually, what he's saying, effectively, you are actually expanding your context,
Hmm.
right? The context may not be additionally you are putting it, but it is something which gets fixed along with your transformer model, right? Which, as a prefix. But this is what you're trying to find the best at expansion of context. That's what
So,
is.
Amar, but the transformer layer does not act on the prefix representation. It just
I
uses the prefix representations to calculate the self-attention on the remaining tokens.
That's exactly what it means, right? So you want to expand the context in such a way that the transformer was not able to give you the right output or basically desired output based on this context. So can we expand the context in such a way that you might be able to get desired output? So what is the best context you can, what is the best way you can expand the context? And in a very loose sense, I am saying, because there are a lot of implementation details that will make this slightly different than context expansion. but you are expanding something in the I mean before that, right? So you are expanding the context in some sense that that you might be able to get the desired output. That is the whole idea of this prefix tuning, right?
Right.
And that's what I was saying in these intuitions, right? A couple of slides before I had, no? If you look at that, let me go back and show you this. So this is what actually prefix tuning, where actually you are kind of like expanding these embeddings here, right? It's more or less context in some sense, right? And here we are having this context slightly more expanded to multiple layers rather than actually this is only one layer, bottom layer, embedding layer, and this is to all layer of transformer. So it's like opening up all the possibilities what you can do for context expansion. Does it make sense, Rudra? Hello?
Yeah, Amar.
I see what you're saying, that those are like fine-grained details. I'm trying to avoid those fine-grained details because, yeah, those are more of like, yeah, maybe we can talk about that in more details offline. Or there is something
Sure, Amar.
intriguing here, then please go ahead. But if it's just this final detail, then I think it's fine.
Yeah, Amar. It's more of finer details.
Okay. Thanks. And then there are a couple of, I mean, quite a few papers has come. I mean, after that, I mean, it's magical to see that only like 8-9 months of a span, quite a few papers which has followed prefix tuning and prompt tuning. In fact, prefix tuning has a lot of follow papers. Prompt tuning has a little less. And one of the paper I think is pretty interesting to read, which I would encourage people to read, is actually prefix tuning version 2, and recently, which Rudra has found out. We were trying to think about some work, and this paper has come, which was very interesting for us to see. Most of the prefix tuning work actually talks about generative models, and this is a work where actually they have basically expanded that to most of the sorts of NLP tasks. I would say not all, at least then. And it actually shows a very nice connection with the fine tuning. So after all these things, they argue that actually prompt tuning can be compared to the fine tuning for multiple tasks and all those things, and that was very nice to see. So that paper actually has a lot of, though it has not too much of novelty as compared to prompt prefix tuning, but it has very good insights actually, I would say. Sorry about that. So yeah, I think that was that is something which I would say about continuous space search for prompting. And I think I'm coming back to those a few slides which I had started in the very beginning. So this is again from the same paper. So far what we have talked about is about single prompts, right? Whether it's in terms of discrete or continuous space, but single prompting. But a lot of work also happened in multi-prompting. And in fact, there are a lot of work after it also happened where people have tried to see whether prompting can also help in learning or fine-tuning the models. So let's go a little bit about what expanding the paradigm. What it means by that can be what we mean by multi-prompting, where and obviously single prompting and multi-prompting, how many prompts you can add after that. Can we do that more than one prompt, and can this help? So we're seeing quite a few papers, but I think some of the first few of them are quite interesting. So let's see them actually. This is actually this one. I think the paper one can find out from here. What are the papers here? A few paper. I think one can figure out paper. The idea here about the prompt sampling is that so depending on the training type and models, different models behaves differently actually, especially for I would say not very large language models, somewhere middle range languages like expansion over BERT and things like that. Depending on training and depending on a data set, actually this my model might behave differently, and it might happen that I mean, for example, if you look at that, right? So these three questions, more or less these 3 questions are asking the same thing. But the way you are prompting to the model, I mean, here prompting simply means that just to, I mean, basically show that very simply that masking is a prompting. So if you put the prompt differently, then basically the answer comes very different. So idea that can we, I mean, since no model is perfect, so can we use multiple models and then ensemble the output and find the basically then the output the one which is going to be best, and for that I think once you ensemble the outputs, I mean many traditional ways one can do that. So idea is you basically alleviate the problem of the model dependency with training and all those things. One can use multiple models and so on, and this is about once you have that outputs, then you how to actually assemble them, and multiple ways one can do that. And I think people have shown that those actually doing that, it is very helpful for to use not very large language models, and it gives very nice performance for many tasks. That's what people have talked about in prompt assembling. Another very interesting thing is, which actually is done very often in GPT-3 as well, which is called prompt augmentation. So situations where actually you have some complicated task, which I mean, this may not be very complicated, by the way, but just to give an example. So suppose the model doesn't know about how to actually add 6 to 8. Such kind of complicated task, if you have the model is not aware of that, then can we train the model by giving some example, some simpler example in some sense. And that's what, so augment basically a few simpler prompts examples in terms of prompt, and then ask the model to do that. So here is a simple example they mean by saying that one, give the first prompt about 1 to 1, 1 plus 1, and give 2. And I think I was showing this example in the very beginning of with GPT-GA itself. And this is very common for many complicated tasks actually one can do on all these GPT kind of models. The bigger the model, the easier actually to do, less and less prompt will be required to augment with. And there are quite a few papers in this line. I think yeah, I mean, I'll not go more papers about that going forward, but let me kind of like, I think that's something what I would say all about prompting in a we covered whatever possible to cover in prompting. And we'll end with some what is the common training strategy and all those things. So so how do, I mean, basically prompt training, prompt based training strategy can be looked from data perspective as well. So and parameter perspective. So we have seen, right? So if you are doing single prompting, then possibly you don't need any training samples, but you are doing the prompt augmentation or multi-prompting or future prompting, the possible some samples of data you can use. And that is especially valid for very large models. Maybe when you go smaller models, you might need to increase those number of samples. So this is one way of looking at that. I mean, basically for all the prompting approaches. Another is how much parameters you are updating. So possibly when we are doing discrete optimizations or discrete prompt search, we were doing very little amount of parameter search. Of course, not, I mean, little, there is no comparison with respect to fine tuning. Fine tuning, you must be doing a lot. And that is why I'm saying, because when you go to continuous search, you are doing little more than discrete optimization level, but it is still much less than fine tuning because we are not touching the language model itself. So these are two views to look, and that's what I was saying. With zero shot, actually, you might be able to see no language. I mean, no data, few shot, few. I think many times few shot is sufficient enough. Sometimes people have shown in some of the work that they use large amount of data as well, like 10K is too much to do. But that might be only for some of the tasks, some of the domain specific tasks. Actually, they have to try to do that. But most of the time, few shot is good enough, and that not even 100, tens of examples are good enough to be able to work with that. I mean, just some. This is just bringing everything on one platform and see what kind of training, prompting-based training methods one can use. People have used around, and what happens in. I mean, in some set, just putting them into one table. So I think the first one is promptless fine tuning, which is like traditional way of fine tuning. And here we are basically all the parameters of the model we are updating here. And I think they're quite self-explanatory here. So tuning free prompting, which is done typically in GPT-3, where we don't do anything, we just give examples and we get a zero-shot prompting basically. And with fixed language model, but do prompt tuning, which is prefix tuning and prompt tuning work, where the additional parameters what we add with the model that we optimize, and so on. And for the fixed prompt, there's some work where they have used actually fix the prompt, and they have using the prompt output, they have updated the language model itself. Those are very task specific, and I think they are very domain. I mean, for very domain specific kind of task as well. So there, the entire language model is basically tuned. Not those prompts what they have fixed upon. I think one of the representative work is PET, and in fact, I mean, taking it forward, some work like PADA, I think not many work is there. One or two work only is there in that area where everything is optimized. I think that's all I wanted to cover actually about prompting. And we have seen, right, so many combinations that happens. Then how to choose what is the right setting we should choose for depending on task, depending on data, depending on type of tuning we want to do. For example, if you have only if you have lots of training samples, you might be able to ignore those training samples and go to promptless tuning, but possibly you can do fixed prompt tuning also, what can be done for this prefixes and prompt tuning. And if you want, you can actually also, if you have more number of examples, you can update your language model also, just we have seen in PT. I mean, if you have very large language model, possibly you don't want to touch them. You want to use them as good as it is, and then we go for tuning free prompting or at max. I think in GPT-3 you will not go for prompt tuning, but some models you might want to do prompt tuning as well. And I think similarly you can see the combinations different depending on what setting you have in your task requirement. Accordingly, you will choose that approach and that set of model. Yeah, so maybe let me pause here for a moment and try to let's try to summarize actually in a very crisp word what we can talk about this, what we can think or what we understand from this prompting. So isn't it like, I mean, maybe I think it will be good to put views here, and sir, please please help us to bring some nice views here as well. So I think what I felt is that, and this is more or less like personal view, I may not be right as well. I think just what I thought, I just want to put it here. Isn't it look like that prompting is something we are trying to optimize, or maybe learning that is a function of the language model what we choose, that is a function of task what we want to solve here, and of course the data what we have for corresponding task. And sometimes we want to actually find this prompt which is tune that, or maybe just choose that from some small set and so on. So that's what it looks like to me. So what we can do is that we can find the best prompt for a task. Also, I don't mean that this is a small thing, first of all, but some sense this is what we are trying to do here, and we are trying to do in a constrained space, and those constrained spaces can be put on through the prompt what we choose, type of the prompt we want to have, maybe language model. I mean, what language model allows us to do. For example, it's a autoregressive model like GPT, or it's a BERT model, and of course, nevertheless, the downstream task as well. So I think in some sense that's what I felt. So I mean, this is what we do in prompting. I mean, that may not be need not to be very small question, or may need not to be solving only small problems. But at a higher level, this is what it looks like. But does it mean that this is just a fancy constraint optimization for prompt search in whatever space we are in? Or we are actually trying to do some kind of querying on the large language model But assuming that large language model has all the information about it, I mean, what view actually not very sure about that. So maybe I'll actually pause here and maybe try to hear some views from you guys. Yeah.
So maybe Amar, I go first,
Yes, sir.
which is so if you can once again go into the mechanism of prefix tuning,
Yes, sir.
because my understanding is prompt engineering is also actually prefix tuning. Is it so? Or is
Yes,
it
that is in one setting. I mean, where we are doing prefix tuning. That's right. That's very much right.
okay? So I say this because we have, I have done some experiments on
Mhm.
two settings. One is uh, converting declarative sentences to interrogative sentences. So, given sun rises in the east, you get does sun rise in the east,
Mhm.
and even little more complicated, like I know the boy who lives in Delhi.
Mhm.
So, do I know the boy who lives in Delhi? So I've given to PALM, PALM.
Mhm.
This is Google's internal LLM,
Yes, yeah.
540 billion parameters. So interestingly, the size of palm is 6 times more than human brain, which is
Oh,
about yeah
okay.
80 billion parameters. That means connections and neurons in the human brain. So this is 6 times more.
Mhm.
So 80 billion is actually small compared to many LLMs that we see these days, right?
Yeah, actually, I didn't know this brain is only 80 billion. That's really good
Yeah,
revelation for me to.
yeah, yeah,
Okay.
yeah. Achha, then, so I gave just 10 prompts for declarative to interrogative conversion,
Mhm.
and it was doing it faultlessly, except in one case where there is what is called center embedding. So center embedding is the boy who lives in Delhi is not coming today. So who lives in Delhi is a sentence which is embedded within a bigger sentence. The boy is not coming today. So here
Mhm.
for center embedding, it took out the verb from the center embedding, which it should not have. So the boy who lives in Delhi is not coming today. So the question should be, is the boy who lives in Delhi not coming today? That is the question. But it converted to, does the boy who live in Delhi is not coming today? So in case of center embedding, it failed. Now, so this is one observation. Second observation is some of the experiments I did with metaphor generation and metaphor understanding. So metaphor generation is the building is very tall, converted to the building is sky high. Converting he is very angry to his blood is boiling. So this is conversion of normal sentence to metaphorical sentence. This is a very difficult problem because you have to carry out a search in the space of metaphors and pick up the right one. The second case is little more easy, where you give a metaphorical sentence. The building touches the sky. Convert it to the building is very tall. So
Okay.
in both cases, the Palm model did everything faultlessly just with about 7-8 prompts. So when I discussed this with people in Google, Path and so on, so they say that all this is happening through prefix. Okay, through prefix tuning. This is what is the surmise, is the hypothesis. So
Okay.
I thought I'd request you to go a little more, you know, detailed into prefix tuning. What, according to you, is prefix tuning?
Uh, I think prefix tuning more or less is about finding basically what is the right set of things I can prepend before a right set of I wouldn't call it token, I would say right set of uh, is actually is because we are searching in the embedding space, the right set of embeddings before before the input text, basically something you prepend before that. And that what something you're prepending, that you find the best one for the particular task through optimize.
I see.
So yeah, you're right. Actually, I think I get your point. What you're saying.
Yeah. So when I give the sentence, I love to play cricket, the question should be, do I love to play cricket? So I love to play cricket is the prefix to do I love to play cricket? Is that so?
What is my original sentence is I love to play cricket, right?
No, prompting is over. And now I give a
Okay.
new sentence. I love to play cricket. And LLM converts it to, do I love to play cricket?
Okay, the task is like do I love, basically task is converting it, right?
Yes. Yeah.
So the model has learned already, and it is actually, oh, okay.
Yeah.
I see. So
And
so
the
far,
problem is
what I was
that
thinking, I didn't.
problem is that in prompt engineering, uh, no parameter is changed in the LLM. No?
Yeah. No parameter. That's the whole idea. Don't change the parameter. Typically, I showed you
Yes.
some of the exceptional cases, which is I don't know why you call it prompting, but they tune LLM also. But typically, if you, I mean, without thinking, prompting means basically we want to leverage the transformers, not touching that. Instead, do something aside. I mean around that.
Yeah.
So actually, what you are saying is more or less like falling in the range of this multi-prompting, right? So you give a couple of examples. Those examples you can have prefixes. But once you give the prefixes, model has learned the pattern, and then after giving that right answers without giving any prefixes before that, right? So you gave
Yeah.
10 examples, right? And that time you might have some, or you are saying that you have not giving any prefixes even before that, during the few shot also, right?
No, I did not do anything other than giving it these pair sentences.
Then, sir, actually, this is multi-prompt. This is few shot prompting where, yeah, I see the point. This is not even prefix tuning. This is something more than prefix tuning actually. So, and
Okay.
this happens only with this very large language model. GPT-J also did that, and not below that actually. GPT-J, GPT-3 also does, and of course, performance depends on that. What you would have seen only with Palm. Uh, so this was a multi-prompting thing. You give a couple of examples of that, and then learns the pattern. And okay, that for
No,
that I
but
don't have
when
any
you
pattern.
say learns a pattern, in what sense is it learning? Because no parameter is changing.
Yeah, no parameter is changing. Actually, that's a very good question. I don't have answer either.
Yeah.
But this is
So,
not prefix tuning.
but it's not
Uh,
prefix to answer.
this is called
Concentrating on the
multi-prompting.
parameter space, like after seeing some examples.
Hmm.
So in the parameter space, there is some constant. So it just looks into those space, like it's kind of a regularization. It does not look beyond those parameter space.
Now the
Like in
question is
the
that why? I mean, because you are not touching the transformer model, right?
maybe
Yeah,
how it is doing that.
That's the question, right? Because
that is a question.
you have not modified anything in that. You just gave three
So,
It would be
examples.
interesting to see the forward propagation during that. How the words are like
And
Yeah,
that's
I mean,
But
yeah,
I have only one hypothesis to do, to explain this, which may or may not be correct. So the hypothesis is that once you have shown the 10 prompts, okay, declarative to interrogative sentences, then uh, uh, and then you give the sentence, new sentence, I love playing cricket. So now this is the conditioning part of a probability conditioning part for calculation of probability of the next word.
Yeah,
So
I agree with that. I think this is just a context expansion that is happening in that.
yeah, so now this this sort of asks the autoregressive model to produce the next word.
Right.
Having seen I love playing cricket, and then it should produce the next word as do, and then the next word is I love playing cricket. This sequence of words is to be produced by the LLM. Now, why it produces do and then I, that needs some investigation. And why not
I-
something else?
Right. Oh yeah, that's
And,
a very good
and
question actually.
having seen only 10 pairs of such things. Okay, after that.
Correct.
Sir,
Yeah.
I have a hunch.
Hmm.
Amar, can you share the slide where you had this example, right? With um, um, say with multi-prompting, where you had an example of 1 + 1 equals something.
Yeah. That's right. This is what is No, this is what is happening there. But I
Yeah,
don't know the answer of that. That's the whole point.
sir. Is it
Yeah.
possible that the large language model is a
Hmm.
collection of multiple NFAs, non-deterministic finite automata?
Mm-hmm.
So it could happen in the training corpus. It has seen examples of this form, say 1 + 2 = 3, and so on.
Hmm.
And for such examples, it has learnt an NFA, and that NFA does the addition operation and not just simple next word prediction. Now,
Mm-hmm.
when you give a couple of such examples to the language model and query for the third, so it moves the language model to that region
Hmm.
where that NFA is present or is modeled. And now when you give a query what is 6 + 8, it's able to answer it. So this is
Mm-hmm.
adding on top of what Niyar just has mentioned.
But I thought the LLM can only retrieve. Can it compute also?
Yes.
Yeah, we cannot actually. We are not touching. We are not asking it to move any. I mean, so,
No,
yeah.
it's highly unlikely there will be pattern of 6 + 8 somewhere in the
Yes,
experiment.
yes, sir.
And
See,
another thing is this feature is only doing well, like it's working fine for the very large models. Let's 176 billion model. It's not working well for the 95 million model or something,
Yeah.
95 billion model. So
Right.
they are also trained with some code, GitHub codes, and also like even if the dataset is same, but with smaller parameters, it's not working. Only with the large parameters, it will working. Maybe the large parameters are able to expand the parameter space such that they are capturing some intricacies that the smaller model are not capturing.
No, but we
I
have to
think.
observe.
Yeah,
We have to observe one thing, very important thing, that when the data is constant, data is same, and you go on increasing the parameters, as you go on doing this, overfitting will take place. Okay, if the
yeah. Apparently,
parameters
that doesn't happen with this language model. That's what. That's what I've read
no,
somewhere.
Yeah.
no. Let me just finish. So, if the parameter is huge compared to the data, that I do not know if it is the case. So then overfitting is must, and the system does not generalize anymore. It only retrieves.
Hmm.
Okay, so so 95 million or 80 million parameter system is forced to generalize, infer, and so on. But large language model with 540, 600 billion parameters can sit comfortably without worrying about inferring. It just has to retrieve. And
yes, sir.
then comes the question of 6 + 8 as a pattern where is equal to 14. Where does it retrieve it from? Okay. And I have also given very unusual metaphors like, you know, a bad workman quarrels with the tool, this kind of patterns. Not exactly this one, but very difficult metaphors, which are not easy. So it falls sometimes, but many times it produces the difficult metaphors also.
Yeah, sir. You remember I showed in the very first time that we can create some alien language add something, some random things in between, it's still able to understand that. So it's not that it's retrieving. I mean, that is nowhere possible to have in data. I don't know if I have that in. I showed that live, right? Doing something. If I have that, I'll
So,
show you that.
so
But
Amar, that might not be entirely true. Uh, sir, adding to your point, there have been couple of papers which
I don't
actually
have.
try to correlate with the large language model capacity with the frequency of terms. So in the previous example, instead of 6 plus 8, if you give some number which rarely appears in the corpus, let's say 97 plus 1243 something, the model fails to compute the correct answer. So the frequency of the terms also play a role. The more frequent it is, it's able to do well.
So adding to Rudra's point, I just actually gave this as an input. It is not working. I gave 2 plus 1 lakh.
No, that's on GPT-J, right? That's
Yeah.
possible because it's a 6 billion, right?
Okay.
Yeah, I mean these are like 540 billion what sir is talking about, and even if you go to GPT-3, it will work very easily. I have seen that.
Okay. So
Yeah, it depends on the frequency of the terms in the training data.
Yeah, I agree.
So,
That's what I'm saying, right? They are not only bigger, they are trained on a large amount of data. Yeah, I agree. I should have mentioned that. They're not only bigger,
No,
they're
but
trained on more and more
Rudra, I
data.
don't think I agree completely because of the metaphor experiment, where metaphors are not very frequent. They're rare occurrences in language. No?
yes, sir. Metaphors and idioms, they rarely occur.
I'll support you, sir, because those languages, those words what I have gave, right, including every word I have put for FOUR. That is never possible to have in corpus. No way it can be in the corpus, but he understood that also as well.
And what did it produce?
So let me see if I can pull that. It produced exactly what I wanted. I mean, basically, in the answer, it gave me. I think I gave like I want to. Let me just recall that if I have some example.
And which LLM you were using?
I use GPT-J itself. See here. I don't know if it is visible now here. The bottom one.
Not very visible. Can you read it?
I'll read it. Let me see if I can make it bigger. Okay. So here it is. Like what actually the question was, what is the capital of Delhi? And I gave like this example. What is the capital of Delhi? What is the capital of USA?
Capital of India. Capital of India, you mean?
Sorry, capital of India. I'm sorry about that. Capital of India is Delhi. I gave answer to it. And instead of writing a clean English word, I added FOUR in all of them. And in the answer also FOUR. And when I gave it the question that what is the capital of Italy, and that in terms of this FOUR, it gave me answer Rome, FOUR Rome. So this kind of words is never possible to be there, right?
Yeah, sure. Achha.
This
So, Amar,
cannot be retrieval.
is it possible to explain this with an NFA?
But the model would have tokenized.
That's a good question, actually. I mean, yeah, whatever explains.
Model would have tokenized what?
So, but the input would have internally got tokenized. So maybe the model didn't. You would have seen the pattern as 4 as one token and what as one token, and you would have realized that after each correct answer I am predicting, I should insert this token 4.
Yeah, Abhishek. So adding to your point, if we think of this as an NFA, right? What is the capital of India? So you have a transition from what to is to the to capital. Now there could be self transitions, like if it sees the word 4 or the token 4, be present in the same state.
So you are saying, ki, Rudra, like LLMs internally create NFA as generating tokens.
I mean that's that's one hypothesis. I'm not sure if that's really the case.
Maybe the LLM itself is the NFA with huge number of states.
Yes, sir.
And then it goes into those areas where it is supposed to go. The question is what is the role of prompting? That is the whole point. because no internal parameter is changed.
Yes, sir. Sir, could it be the case that if we consider NFA, a very large NFA, and there are various subregions in the NFA, which when I go to that particular region, I can retrieve a particular kind of answer. Let's say one subregion which given a sentence converts it into the interrogative form, another subregion which does this retrieval or computation of addition, and another subregion which is able to identify the metaphorical part in the sentence. Now, how do we reach from starting point to that particular region?
Yeah.
So probably the prompting is the path.
Guiding path.
Yes.
Yeah, which is placing the LLM in that region.
Subspace.
Yeah, some mystery really.
Yes, sir.
Okay, so any point from anybody else? Any question, comment? Okay, so if not, then we would like to thank Amar and Rudra profusely for taking their valuable time and teaching us about prompt engineering. And for me personally, it is very satisfying because the students have been excited by this. They're already enthused to do experiments using prompting. And quite a few students said that they have shelved other things and are doing experiments with prompting. Okay, so which is nice. You have generated a lot of excitement and enthusiasm about this in the INSE field. Thank you for that. And so today was the last lecture on prompt engineering. From next time, we'll go back to probability and NLP and ML, revising or taking up new things. So thank you, Hamar and Rudra.
Yeah, thanks a lot. It was our pleasure. Actually, if we have couple of more minutes, then actually I want to give a little more excitement in terms of our views, which might not be correct. So I paused there because I thought that's a logical point to pause. But something we were thinking, we and Rudra were getting puzzled about that, and we didn't have answers. So we thought, okay, let's bring our views only, okay. And let me just scroll very faster here, but I'll put that across to you as well, these things. So I think one of the, I mean, what we're thinking is it, I mean, leaving that multi-prompting thing aside, rest of the other prompting actually looks like more or less is like querying the language model, large language model, right? So is it something which we are trying to find what is the right set of queries we should put actually in before or somewhere along with our input sentence? And the whole assumption is that the language model knows everything about us. So basically, we are querying some knowledge from that. And isn't it like we are trying to find? I mean, this is one view of looking at that. Isn't it we are trying to find what is the right set of query, or let me learn. Let's say other way, right? Because we are learning that prompt, so we are learning a query language there. And if you see, we have seen in prompt prefix tuning and all those approaches, right? The language is not very much. Even if you learn the language, query language or prompt language, then it's not very much we understand about that. So maybe it is something meta language, and if that is some which what we understand as a human as well, maybe understandable to us, then maybe that is something which one can generalize is to multiple domains. I mean, instead of getting it very specific, can that be done for more generalizable across the domain, across the task, by just understanding what is the best prompting. GPT-3 may not be. I mean, GPT-3 or Palm. I mean, those questions might slightly become different, but more or less, this is what one view we're thinking about.
I see. Okay.
And maybe today, I think this is something, maybe if we get chance, we might actually want to discuss more on these kind of fronts.
Yeah.
And one more actually view, which is more from language model view. So the way what is happening by prompting? I mean, ultimately we're trying to query the language model, but what is the way language model actually stores all the information? I mean, the only way we can think about it, which might be very myopic, but we can think about that the language model is basically stores information, something in the form of like, if we consider only, let's say only the generative models, right? So in the form of like conditional, context conditional, I mean, probability model, right? So this general language model is something which might not be the best language model for a particular task. And when we see fine-tuned model, that may be the best for a particular task, but may not be good to basically adopt it. So by prompting, are we trying to figure out the deficit and somehow compensating that deficit? I think this is what you were also saying, sir. So we are context, right? So how do we, is this what we are doing? We're expanding the context here. So is this what is happening? If that is what is happening, then I mean, is this a limit of prompting? That this is the best what we can do is that we can go till the fine-tune model, but that may not be very bad, because what fine-tune model? Because bigger and bigger model is actually not only fine-tuned for a task, it is also seeing large number of basically bigger data set and bigger parameters as well. So this limit also is moving up. But still, whatever limit is there, we are just chasing that, and by doing prompting, I mean, is this right to understand? And if that is right, then it will open up a lot of like questions that we can actually look from the task perspective.
So all these LLMs are transformers, right?
Yeah.
Ultimately. And how does the number of parameter increase because more layers are added, or what?
Yes, more or less, this what is happening. I mean, this is not the
More
only thing.
layers
I
and
don't.
more hidden size also, hidden layer size, embedding space.
Oh,
Right.
no, I
Like
mean
GPT-3 has some embedding space of 1,000.
embedding
Like
space.
what?
Space means
I mean
what?
token embedding size.
Basically, it's like what you're saying is like expansion in terms of layer size. There's vertical expansion. There is lateral expansion also happens. That's what he's
Oh,
saying.
I see. Both, I see.
So like in bot, each token embedding was of 768, but GPT-3 large model, I think the each token embedding was of 10K size. Something.
Right.
Oh,
That's
okay.
lateral expansion that's
It's
happening.
very huge. 10K, how many intricacies that is capturing regarding each token?
Actually, from architecture point of view, I didn't see much of a difference that is happening in these language models, except the expansion type. But there is a lot of tricky way of training that happens. I mean, basically, in some sense, how to infuse those data into the model, that there a lot of tricks has come. I still want to call it trick because that not much of a research backing is there for this. But there are a lot of tricks that has gone. If one wants to look at that paper of this T5, there we can see that how many tricks people have played about that, and then going forward, all the papers that they have shown.
Oh, I see. Okay, so I have another meeting. I'll have to sign off. Huh?
Sure.
Thank you very much. Thank you.
So thank you very much, everybody. Thanks. Yeah, we'll be happy to
Everyone.
discuss more on that for anybody who wants to discuss. Yeah. Yeah. Thanks a lot for putting views.